Okay, let's go ahead and jump into section 2.2 here. We have trigonometric functions of non-acute angles. So what happens if these are bigger than 90 degrees? How do we deal with those? And it's all about finding a reference angle. Okay, reference angle, theta, written theta prime, is the acute angle made with the terminal side and the x-axis. Okay, the reference angles are always positive and between 0 and 90 degrees. So I take an angle, and whatever angle that makes with respect to the x-axis, that's the angle that I use as a reference. Okay, for example, if I have 294 degrees, okay, if we look at this, oops, right pen. If we look at this, we have, well, where's 294 located? It's actually located, if we look at the fourth quadrant here, it's in the fourth quadrant. Why is 294 in the fourth quadrant? Well, if we go 90 degrees, that's here. And then if we go to 180, that's here. If we go to 270, that's here. So we're going to go just past 270 to 294. Okay, we're going to go 24 past 270. Okay, and so we want the angle that is made with this axis here. Okay, with the x-axis, not the y-axis, the x-axis. Okay, so at 294, how far away am I from the x-axis? Well, the x-axis is 360 degrees. If I keep going here, I would be at 360. So I want to know what's the difference between 360 and 294. So 360, let me go down here. 360 minus 294, and that comes out to 66 degrees. Okay, is my reference angle. So the reference angle is actually the angle that's in quadrant 1 that refers. So the angle that refers to this angle, I draw that too well. That's better. That refers to the angle that's made with the x-axis is 66 degrees. Okay, and there's a reason we're going to use these reference angles, because they help us find the sine, cosine, and tangents of the angles. Okay, what about 883? 883 is much bigger than 360. And so we're going to go around, change this. There we go, thanks. Okay, and so we're going to go around the circle many, many times. So I want to find what angle is the same as 883, but within one rotation. Okay. So what is basically the coterminal angle here of 883? So this is going to be minus 360. That's going to get me down to 523. Minus 360 again, and that gets me down to 163. Okay, so now we know it's 163. So where is 163 located? Well, that's located in the second quadrant. Why the second quadrant? Because again, the first quadrant is from 0 to 90, and the second quadrant is from 90 to 180. So the angle that I'm looking for is 163 degrees. Okay. So it's going to be somewhere between 90 and 180. Okay, but I want the reference angle. So how am I going to find the reference angle here? So the reference angle is going to be the angle made with the x-axis. Okay, the angle made with the terminal side and the x-axis. So that if I were to continue to go all the way to the x-axis, that would make 180 degrees. But I'm just shy of 180 degrees. I'm 163 degrees. So how am I going to figure out what that angle is? That's the reference angle. And that reference angle is going to be referenced to an angle in quadrant 1. Okay, you'll see that the reference angles that basically are the mirror images of the original angles. Okay, and so this angle, how do I find that? Well, it's 180 minus 163. It's the difference between the angle and the angle that would be made with the x-axis to get to the x-axis. So 180 minus 160, that's 17 degrees. Okay. Okay, to find a reference angle of an angle greater than 360 or a negative angle, first find its coterminal angle. Okay, we did that. Okay, finding a trigonometric function value. Find the reference angle, find the trigonometric function value for that reference angle, and then determine the correct sign or value. Okay, so let's do that. So the sine of negative 150. Okay, so let's find the reference angle for negative 150. So negative 150, okay, goes here. Okay, if I go negative degrees 150, so that would go there. So how far away am I from the x-axis? That's really what I want to know. I want to know if I go negative 150, oops, let's make that the angle there. If I go negative 150, then how far away am I from the x-axis? Well, what would the x-axis be? The x-axis would be negative 180. So if I take negative 180 and I subtract off negative 150, I get negative 30 degrees. So I'm at negative 30 degrees. So we find a reference angle for this. The reference angle would be actually 30 degrees. Okay, it would be rotated 180 degrees. It would be a 30-degree angle here. Okay, so the reference angle would be that 30-degree angles. It may make a little bit more sense to do it with positive numbers. If you want to make the angle positive, you can. Instead of a negative 150, we could go all the way around here. If we do 360 minus 150, or negative 150 plus 360, we would get 210 degrees as my angle, my original angle, theta. Oops, not zero, theta. Okay, my original angle would be 210. That's the kind of the coterminal angle. So we find the coterminal angle first of 210. So 210, and then how far away from the x-axis am I? Well, the x-axis is 180. So if I do 210 minus 180, I get that 30-degree angle that I'm looking for, okay, as my reference angle. So either way, you know, I get that 30-degree reference angle. So now I want to know, well, what's the sine of 30 degrees? What's the sine of 30 degrees? Well, from our previous section, we knew that the sine of 30 degrees was equal to 1/2. Okay, but that's not the answer, because 1/2 is what it would be in the first quadrant, quadrant 1. What are the sine values in quadrant 3? Well, the sine is the y value. And we're looking at quadrant 3, and everything is negative in quadrant 3. In quadrant 3, all the y values are negative, and so are all the x values. And so the sine of negative 150 is equal to negative 1/2. And we could check this by plugging it into a calculator. So if I took the sine of negative 150, I should get negative 0.5, an ideal. Okay, so which is 1/2. Okay, number 7, evaluate the sine squared of 45 degrees minus 3 cosine 135 minus 2 tangent of 225. So I really want to know, well, what's the sine squared. This sine, this little 2 here means take the whole sine of 45 and then square it. Okay, it's a little counterintuitive, but this means sine of 45 squared. This is 3 times the cosine of 135 squared. We don't square the 3, just the cosine. Minus 2 times the tangent of 225. Okay. Okay, so again, I want to get these reference angles. Well, the 45 degrees is its own reference angle. It's between 0 and 90. So the sine of 45 from the last section, I know that's radical 2 over 2. I'm going to square that. Plus 3 times the cosine of 135. Where is 135 located? 135 is located in the second quadrant. And the cosines there are negative. So the cosine, so I want to find the reference angle for 135. So the reference angle for 135 is going to be 180 minus 135, which is 45. So we know that the reference angle here is a 45-degree angle. What about the 225? What's that going to be? 225. Well, 225, that's going to be 90, 180, 270. Oh, it's in the third quadrant. How can I find out what the reference angle is? Okay, the reference angle. Well, I want to know how far is 225 from 180. And that's 45. So they're all 45-degree reference angles. Okay. They're just all in different quadrants. The 135 is in quadrant 2, and the x values, or the cosine, is negative there. Oh, okay. So I know that this is going to become, let's just bring this down, radical 2 over 2 squared plus, this is 3 times the cosine of 135, but again, the 135, that's a negative for x because it's in quadrant 2. And so this is 3 times negative radical 2 over 2 squared minus 2. Now I want to know, well, what's the tangent of 45? Well, the tangent of 45 is 1. But what about in the third quadrant? Well, cosines are negative, sines are negative, but tangents are positive. And so this becomes 1, 2 times 1. So now we're going to square these guys. We're going to get radical 2 squared, that's just 2. 2 squared is 4, so this becomes 2 fourths. Plus 3, negative times a negative, that's a positive. And so we're just going to get radical 2 over 2 times itself is going to be, again, 2 over 4 minus 2. 2 times 1 is 2. This is going to be 2 fourths plus 6 fourths minus 2, which is 8 fourths minus 2, which is 2 minus 2, which is 0. That's kind of cool. Okay, let's do part B. We skipped over part B here on the, I kind of went horizontal instead of vertical. That's fine. Let's find the cotangent of 780. Okay, the cotangent of 780. Okay, so the cotangent, let's find the coterminal angle first. Let's subtract 360 from this. Okay, and I get 420. Subtract 360 again, and I get 60 degrees. Okay, so what I really want to find is, you know, the coterminal angle here is 60 degrees. 60-degree angle here, and I want to find the cotangent of 60 degrees. Well, the cotangent of 60 degrees, okay, is equal to the cosine of 60 degrees over the sine of 60 degrees. The cosine of 60 degrees over the sine of 60 degrees. So that's my quotient identity. So the cosine of 60 degrees, well, we know what that was. That that cosine of 60 degrees, that's the x value. So the x is smaller than the y, so the 1/2 is the cosine of 60. And so what's the sine of 60? The sine of 60 is radical 3/2. Okay, again, from that special triangle that we had. Okay, and so we want to multiply these or divide this. Dividing by a fraction is multiplying by the reciprocal. So this becomes 2, 2, and then we get 1/√3. We've seen how to deal with that before. 1/√3 multiplied by radical 3/√3, and we get radical 3/9, which is just radical 3/3. So the cotangent is radical 3/3. Okay, note, we can find the angle measure given a trigonometric function value and interval. So we can find the angle measure if we're given a trig function. Okay, so we want to find the angle, kind of go backwards. So if we're given the sine is equal to negative radical 3/2, then what are the angles that could produce that? Well, let's look at the angle that produces the sine of radical 3/2. What angle will give me a sine value of radical 3/2 from in just the first quadrant? Let's just look at just the first quadrant right now. Okay, and yeah, we just talked about that. Okay, and that's a 60-degree angle. Okay, so the sine of 60 degrees, okay, the sine of 60 degrees is radical 3/2. Well, how would I get a negative for the sine? Remember, the sine is the y value. That's the sine. The sine is the y value. Okay, in my right triangle. So the sine is the y value. Okay, if I go over here and do kind of a mirror image, what's the sine value there? Wasn't kind of a good mirror image, but it is what it is. Okay, well, that's still positive because the y's are positive above the in quadrants 1 and 2. So we'd have to drop down, okay, to quadrant 3 and quadrant 4, and our reference angle is going to be 60 degrees. Our reference angle is 60 degrees. So what angles are going to be are these angles that are going to give me negative radical 3/2 and negative radical 3/2 for the sine function, for the y value. And they're all going to have a reference angle of 60. Okay, so well, what is 180 minus 60? 180 minus 60, that's 120. Okay, that's 120 degrees. So 120 is there. That is a reference, 60 is a reference angle for 120. However, it gives me a positive, so I can't use 120. What about the next one here? How would I find the next angle using the reference angle of 60? Well, instead of subtracting 60 from 180, let's add 60 to 180. And that's going to become 240. Oh, okay, so this had to have been a 240-degree angle. Okay, would give me a reference angle of 60, but would drop me down in the third quadrant. So that's 240 degrees. So that's one answer. Is 240, the sine of 200, that's going to give me a negative here, a negative. Okay. So the sine of what angle is negative? One of the options is 240. However, there is a third or a second option, which is in quadrant 4. So how am I going to find the reference angle for, or the angle that has a reference of 60, but is in the fourth quadrant? Well, I'm going to take 360, I'm going to subtract off 60, and I get a 300-degree angle. Okay, so this is 300 degrees there. And so we had two solutions, 240 and 300 degrees. And one thing to note is that radical 3/2 in a calculator is approximately 0.866. Okay, 1/2 in a calculator is approximately 0.5. Radical 3 in a calculator is approximately 1 point, I think it's 1.57, is that right? Radical 3, 1.732. Okay, so that's approximately 1.732. 1.732. And then radical 2/2 is approximately 0.707. So these are good values to have as a reference. Okay, you might even want to memorize these ones. Because if we wanted to check this on a calculator and say, well, what's the sine of 240? That should give me 0.866, but have a negative value. Okay, so if I go the sine of 240, yeah, that gives me negative 0.866. What about the sine of 300? Yep, same thing. So it is, and if you were to do radical 3, let's do the negative here. Negative radical 3/2. 2. You would see that that's the same, it's the same value. Okay, I will see you in the next section. That's it for this one.